Welcome back to Data Science. Today, I brought you another amazing topic about Microsoft's new large action model, which is called LAM. So, this is developed by Microsoft. Now, what it can do? It can perform some tasks in Word. So, this is next level stuff. LAM is not just another AI that only talks and gives instruction. It actually performs the task. So we're talking about an AI that can actually perform the tasks in apps like Microsoft Word, Excel, and PowerPoint. You know how traditional AI like GPT-4o, as we already know, can generate text and give advice. Well, LAM can do those tasks for you directly in the software. So, what makes this AI different? Let's get right into it. So, what is LAM? So, what's the deal with LAM? I mean, well, traditional AIs can understand the text and even generate responses. But what if you want your AI to actually interact in your system, like open a file, create a table, format a document? That's where LAM comes in. It's an AI that can operate window programs on its own. And what it can do, LAM can also take your instructions, whether they're text, voice, or images, and turn them into real actions inside Windows application. Whether it's navigating Excel or creating a new project in Word, LAM can handle it. So how does LAM work? Now let's talk about how Microsoft trained LM to do all this. They use a combination of supervised fine tuning, imitation learning, and reinforcement learning. So it's a four-phase process. Like as you can see here, these are four phases of the whole process. And first, what it happens? First, LM in this phase one, LM learns to break tasks into logical steps. Then it gets examples from GPT-4o to learn how to handle different tasks. So first it will divide the tasks, like separate the tasks, and then it will take examples from GPT-4o to learn how to handle different tasks. Now after that, what it does, it gets to experiments, means it will find solutions to tasks that even GPT-4o can even solve. Finally, the reinforcement learning kicks in, means the self boosting exploration, which is the reinforcement learning. Then it will fine tune its decision making. It's like teaching an AI to plan, act, and also adapt in real time. And if you see the real world applications of LAM, means what they can actually do. So if you see here, there's an example for buy a jacket for men. What LLM will do, LLM will give you the series of steps, like first open an online shopping website, then after that search for a jacket for men, and then go through all jackets. But LAM, what it will do, first it will go to the website, it will write like jacket for men, and then it will go through all the jackets, and then step three, it can even do the checkout or add to cart. So this whole process, which the LLM just gives you the instructions, LAM will do these tasks in the system, means they'll actually do the tasks. And another real world applications of LAM is Microsoft Word and Microsoft Excel, which Microsoft has tested it out. Like in scenarios, they have tested it out in real world scenarios using Word and Excel, like from simple tasks like formatting text to more complex operations like inserting tables or pulling data from files. So LAM shows some impressive results. It doesn't just generate text based instructions, it actually interacts with the app, performing each task step by step, just like a human would. And the accuracy and efficiency of LAM's execution are way beyond what we have seen from the typical AI models. And it's not just about doing tasks, it's about doing them right. If you have a look at the testing, during testing, LAM, it completed the task successfully 71% of the time and even outperforming GPT-4's 63% success rate when it was tested without visual inputs. And LAM even outperformed GPT-4o when it came to completing tasks faster and more accurately. I'll show you here. Okay, so for the test case, they built based on Mistral 7B and they like let it loose in the word test environment. So, how I already told you that it completed tasks successfully 71% of the time, significantly outperforming GPT-4's 63% success rate without visual information. It only needed 30 seconds per task compared to GPT-4's 86 seconds. And when GPT-4o got visual information, it was more accurate with a 75.5% success rate. And how the training was built. The training data was built. First, the team started with 29,000 task plan pairs collected from Microsoft documentations, WikiHow articles, and also Bing searches. To expand this further, they used GPT-4o to transform the simple tasks into more complex ones. Like a basic task like create a drop-down list evolved into create a dependent drop-down list where the first selection filters the options in the second list. Now, there was the data evolving strategy also, like there was data evolution also. Now what it did, now this strategy helped them grow their data set to 76,000 pairs, a 150% increase. And from all these examples, about 2,000 successful action sequences made it into the final training set. And so what does this mean for the future? Microsoft researchers believe LAM could be the beginning of AI that's capable of doing complex tasks across different operating systems. Right now, LAM's focus is on Windows apps, but the potential to extend this technology to other platforms like Mac OS or mobile devices is huge. For example, if you imagine having an AI assistant that not only give you advices but actually executes your tasks across all your software. So, what do you think? Is LAM a glimpse into the future of AI, or do you think it's moving too fast? Let me know your thoughts in the comments below. As always, thanks for watching. And if you like this video, give it a thumbs up. And thanks for watching. And I'll see you in the next one.